Assalamu alaikum, my dear viewers. How are you? Hope you are doing good. Well,
Now, there are some advantages and disadvantages as well for the mean deviation. So that's why we have to go for the standard deviation and variance. But first of all, we have to look the merits and demerits. The merits are for the mean deviation are easy to understand and compute based on all the observation. Basically, this is the main advantage though which we have adopted the mean deviation. कि ये base करता है सारी की सारी observation से. Till that, usse pehle we read the range. Range is just emphasizing on the two values, extreme values, and get rid about the majority of the data. And the quartile deviation is catered 75% of the data. Then mean deviation about mean and median take into consideration all data set. This is the major advantage. But on the other hand, mathematically, the demerit is that illogical to assume all negative as positive. So that's why this is the major disadvantage when we are taking the absolute, and the major advantage is to cater it all the observation. But still there is a leakage. So we have a room to discuss something else, which is known to be the variance and standard deviation. The standard deviation and the variance is basically known to be the very, very good and pure measure. You can say pure in the sense, not in the number. Firstly, I would like to discuss the variance and then standard deviation. As you people have been observed, what we have done in the mean deviation about mean, हमने क्या किया है? हमने किया था average sum over n लिखा हुआ था ना उसके फॉर्मूले में. So that was the average absolute deviation of the observation from their corresponding average. चाहे mean हो, चाहे median हो. But here what we are doing for the variance case, we are taking the average sum over n. ये वाली चीज summation और n का मतलब होता है average करना. किसको average कर रहे हैं हम? Average square deviations. हम square कर रहे हैं deviations को of the observation from their corresponding mean. So that is known as to be the variance. Fine. But here again the one disadvantage we can observe that as we have done for the mean deviation about mean में absolutely है हमने हर negative को positive कर दिया है. So इधर भी हम क्या कर रहे हैं? इधर भी तो हम square कर रहे हैं ना अपनी deviations को. ठीक है ना? What we are doing? We are taking the square. Now we were discussing that this is the average square deviation of the observation from their corresponding mean. So here we are again taking the square, and the major disadvantage again comes over here that we are squaring the deviation over here, as well as the units. For example, we have done the example of the dollars. So when we will report the variance by this formula for that particular question, so we will report dollar squares, like our units will be in terms of square. So get rid all this mischiefs, whatever we have observed in the absolute deviations like range, like quartile deviation, like the mean deviation and the variance as well. We get rid all these or overcome all these mischiefs or mistakes in standard deviation. Now the standard deviation is the very, very good and excellent measure of dispersion, which is known as the standard deviation of observation is defined as the positive square root of the mean of the squares of deviation of observations taken from their arithmetic mean. What does it mean? It's as equivalent formula as you have seen for the variance. Just we have to take the square root on both sides. जब हम square root ले लेंगे तो जब s के ऊपर square जो था वो conceptually और mathematically cancel out हो जाएगा और this measure s stands for standard deviation. And here when you are taking the square deviations, आप जब square deviation ले रहे थे तो by the end आपने क्या किया उसे conceptually भी mathematically भी उसे cancel out कर दिया under root लेके. And similarly, as I have given the example priorly, कि मेरे पास अगर डॉलर में यूनिट्स थे तो जब मैं वेरिएंस लूंगी तो मेरे पास डॉलर स्क्वायर आ जाएगा. बट जब मैं उस डॉलर स्क्वायर का अंडर रूट लूंगी तो फिर मेरे पास ओरिजिनल डाटा के यूनिट्स यानी कि डॉलर्स आ जाएंगे. मीन्स टू से it just wants to say here that standard deviation is covering all the leakages. Number one, it's covering the entire data set. ये सारे के सारे data set पे काम करता है और किसी को मिस नहीं करता, as the range and quartile deviation missed, and as well as it's taking the original units of the data set which has been missed by the variance, जो variance उसको scare करके present करता था, or as well as it's catering the problem of the absolute deviation. ये कोई हमारी डेविएशंस को पॉजिटिव भी नहीं कर रहा, ठीक है। अगर हम स्केयर ले भी रहे हैं तो हम उसको बाद में एंड पे अंडर रूट कर रहे हैं। So kindly keep it mind कि ये जो standard deviation है, this is one of the best measure of absolute deviation. Kindly have a look. इसको देखिए. And similarly, this is by definition formula. And this is by shortcut. Alternatively, आप इसको ऐसे भी use कर सकते हैं. Both the formula will give you the same result. ये वाला formula भी और ये वाला formula भी हमें same result देगा. So now we will go for one application for that. हम इसकी एक एप्लीकेशन की तरफ चलते हैं. Kindly have a look. So that was the example for the variance and the standard deviation. So it's a solution over here. Just the difference of over here is the billion scale, and in standard deviation it's the billion, directly measured in the original units. So we have to go to the next example quickly. Just have a look. And this is by definition formula we have been used over here. In the previous example, we have been used the shortcut formula. X square n minus x square n whole square. Okay. And in new example, this example, we have used the by definition formula. That was summation x minus x bar whole square by n. And here we have taken all the consideration, the calculations. Just substitute it over here and write it over here. And here the units are 1000 squares again. Some practice questions like that. Coefficient of variation. This is the relative measure. And to whom we are discussing the coefficient? This is the standard deviation ki coefficient. Like we have read the range or uska coefficient, like the quartile deviation, uski coefficient, like the mean deviation, uska coefficient. So what about the coefficient of variation is known as the standard deviation ki coefficient ko coefficient of variation कहते हैं. CV से इसको denote करते हैं. The most important of all the relative measures of dispersion is the coefficient of variation. Coefficient of variation is a measure of the spread that describes the amount of variability relative to the mean. And it can be in terms of percentage you can take. So that is the standard deviation of the data set which you have already calculated. Certainly the units of the standard deviation is the same as the data possessed. And then you have to divide it, take the relative. And the units of the mean certainly the same as the data set. So it will be cut it off and you got it, the pure number from this formula. S over X bar into 100 in terms of percentage, you will get the pure number. So the coefficient of variation has a greater practical significance. And it's usually used, my dear, to compare the consistency between the two items, two individuals, two players, anything. It has make the comparison between the two things whenever we are interested कि कौन सी चीज ज्यादा consistent है. So जिसमें variability कम होगी, याद रखिए, वो ज्यादा consistent होगी. जिसका coefficient of variation कम होगा, that is more consistent considered to be. ठीक हो गया जी? And this is the usage over there. Kindly have a look. The series of groups for which the coefficient of variation is greater is said to be more variable or less consistent. जिसमें ज्यादा variability होगी, जाहिर है वो less consistent कहलाएगा. On the other hand, that will be called the more consistent. Compare the dispersion in different sets of data, particularly the data which differ in their means or differ in the units of measurement. Because units of measurement differ होने से हमें फर्क नहीं पड़ता, because हम क्या ले रहे हैं, coefficient ले रहे हैं. Coefficient measure is a relative measure. So now we have to go for one example. Have a look. It's over here.
Thank you very much for watching my video.